will be more on the milling rather than turning programming. Actually, there are some of the differences between milling and between the turning programming. And this difference is not because not G0, it's when I use G0 in the turning or I use G0 for milling, it will be different. No, for the G code, it is the same. Use there or there. Use in the turning, use in the milling, use in the drilling. If I use the G code, so it is the same G code. But some of the operation, I don't need to use all G code that I know, for example. So for example, in milling and turning, we don't need to use, for example, G17, G18, G19. In milling, we don't need to use G32, like this one. So we have a list of G codes. Some more, most of them are used in both or on all operation of the CNC machines, turning, milling, drilling, and so on. Some codes are more specific for CNC milling. Some codes are more specific for CNC turning centers. So we are not going to go in details for this part. So when we talk about some program, it will be in this chapter will be more on the CNC milling. At the end of the chapter, we are going to highlight some of the examples for CNC lathe or CNC turning centers. Okay. So this will be the chapter content, and here this is the list of content for this chapter. As I told you, we are not going to, in the previous chapter, we highlight just definition for each code and how to use this code in one programming block or address. But here we are going to take a complete example. For example, as we can see here, programming for linear profile. Last time we said G0 is, for example, G1 is used for linear cutting or linear movement of the spindle. Here we are going to talk about programming linear profile. That means we are going to use this G1 to conduct a complete task for cutting using milling machine. Programming of circular profile that we mentioned before, for example, C2, C3, clockwise, counterclockwise. So we are going to use this as a complete profile to conduct milling for CNC milling. Then we are going to talk about part programming for milling operation, programming hole of operation for drilling operation here. Until the end, we are going to highlight some part of the lathe or turning centers programming. So this chapter will include a lot of examples, for coding, and it will be like the main or the content of this chapter will be the main or the core part of the course, because it includes a lot of G coding program development. So here in this chapter, I am going to include the list of G codes. Previously, we just highlight some of the most commonly used G code. In this chapter, I'm going to list all, or I need to highlight to include all the G code. It will be for your reference, since you are going to take lab for this course next year and or next sem. So maybe you are going to refer to this reference G code or list of G code and M code. So here is the list of the G code starting from G00 with some definitions for each code here and where we need to use it. Is it for milling? As you can see here for G20, 12, G13, circular bucket milling, clockwise, counterclockwise, circular motion, 18, 19, 17, circular motion XY plane, and so on. So all these list with their definition for G code. You can see how long or how big is this list, which include lot of G coding. So as I told you before, not all G code are used for the same machines. It depends on the type of the microcontroller of the machine. It depends on the manufacturer of the machine. There are some manufacturer or some type of microcontroller which use some G code which is not used by other machines. Okay, so this depends actually. Each CNC machine comes with its user manual or instruction manuals. Inside this instruction manual, they define which codes can be used, which code are support, and so on. So it's not I mean, it's not for all type of machines. It's not for all type of the microcontroller that use with the CNC machines. Some also, it depends on operation. Some are used for milling operation. Some are used for drilling operation. Some are used for turning and lathe operation. And also the most are commonly used between all these type of operation. Maybe you will ask, do we need to memorize all this code? Not all, but some of the most commonly used coding you need to memorize. Maybe during the test, during the exam, you will be asked what G0 means, what G01 means, or what the machine do in this line, what the machine do in that address, what the machine do at this block, and so on. So you should understand, or you should at least practice more programming for using the G code, so you become more familiar with some of the main commands for the G codes, which is frequently used in the programming of the CNC machines. You can see here, last time we didn't mention for G11, G12, and so on. So all these, for example, come for work offset. Or some of them they use with the with the 5-axis machine. Some they use with the 4-axis machine, and so on. So some of them are more specific for specific tasks. So they are not commonly used. Not like some of the G code that we highlight in chapter 4, which is commonly used for the CNC machines. I mean, as engineers, uh, these all available. I mean, you just click or write in Google, you find the list. Also, as I told you, each machine come with each instruction manual and include all the G code and M code, and also the program that already include in the memory or into the microcontroller of this machine. This and also the M codes is more details here, explaining the list of all M codes from M00, M19, M20, M21, and so on, with their commands here. Okay, last time we talked about this type of parameters, which is speed and feed rate. We said we have some formula to calculate these values. Okay, to calculate the values, if we have such question that I provide you or I give you during the for the assignment, you have formula, you have calculation, you need to you given some information, you need to calculate. But in practical, you are not required to do a lot of calculation, because there is some of the standard or recommended speeds and recommended feed rates for the machine, for each machine. For example, if we have drilling, what are the recommended value for the speed? What is the recommended value for feed rates? What's the recommended value for drilling? Yes.
Sorry.
Okay. So as we can see here, we have the material. Based on the material that we are working on, is it magnesium, aluminum, is it stainless steel, iron, copper? Depends on the material, and we have some average for drill speed. For example, here for the speed 300, 252. Previously in chapter 4, you see these numbers after S or after F when we mention in the program S300 or S70, S60, and so on. So these values actually come from such table, because as I told you, each machine will have its own parameters, its own rated values, and so on. So also each material, it has its own recommended speed and feed rate operation for the machines. So here for the speed, here we have for the feed rate, for drilling feed rate. This one for milling, also the same speed and also feed rates here, based on the materials and based also on the operation here, face mills, side mills, end mills, and so on. It depends also on the location or on the which part of the workpiece you want to work on. Okay, so this part is more on mechanical characteristics, more on the material characteristics. So for us, we are not going to go in detail of this one, and we are not required to. If you have question, for example, in the test or in the exam, it will be, you will be either given these values or you will be asked to calculate this value based on other values. I mean, same like either in same on the case of the assignment, they give you some values and you are required to calculate based on using some formulas, or you will be given the value as we will see later on in this exam, in this chapter, then to use this value in your coding. This for turning also recommended and fitted for turning. The same here based on the material starting from magnesium until we have titanium here, either for the speed or also for the feed rates. Okay, this is the just recap on the what is the common format for the block. As we said before, we have sequence here or number of the block. We have the preparatory function, which is G, any type of G here, starting any of the G that we listed before on the table here. Then we have also the dimensions or the coordinates, which is X, Y, Z here. Then we have the feed rate, the spindle, the tool function, and the miscellaneous functions. As we said, the sequence should be in this sequence in the block of programming, and it's not required to have all these codes. Maybe you have one other, I mean one word, you don't have the other word, it's still okay. It depends on what's the required operation that you need that the machine need to be performed. Is more details there, block sequence, miscellaneous for specific. I mean, maybe you will be given such block in the test or in the exam, and you will be asked to make a comment. Okay, I give you the block. I ask you what this block means, like we did last class in, I mean, for chapter 4. Okay, for N1, for example, say this block sequence. This one is code for tool change. This the tool number. This for operator for I mean comment operator, then we have the comment after the comment operator. So after the comment operator here, if you have any writing or any words here, it's a comment. Comment means just to define what this block can do. Okay. Also the same here, you have the number, I mean the sequence number, you have miscellaneous function, which is term spindle on, then you have spindle speed here, which is 1500. Same here, you have line number, you have BRI code, which is G90 for absolute. You have the the code here for interpolation, which is G1 interpolation. Then you have the definition for the coordinate. After that, you have the filtering. Okay, this is the program structure we already also mentioned before, but we are going to take it or to apply this program structure on the specific programs. I mean, we are going to take some program and we are going to define which part is the header of the program, which part is the content or the body of the program, and which part will be the end of the program. Okay, so this help the programmer to build or to structure their program. So in the beginning, they need to define some of the setting parameters, some of the definition for the program, what this program is used for, what is the number of this program, or what is the title of this program, and so on. Some of the setting before the machine starts to perform the task on the workpiece. After that, you are going to use the going to use some, maybe you need to use some of the comments there. Comments here will help the programmer or help the operator to understand what this program can do. Okay, then you have the end of the, the coding or the main NC blocks or NC coding here, which define the movement, speed, like fast movement, linear profiling, circular profiling, and so on. Then at the end, you have the definition for them. Maybe during this operation, you need to change the tools. So each time you need to change the tool, you need to stop off the spindle, make coolant on. Again, you need to restart again and go to the reference point or to the part, the point of origin here, 00, or the reference that you already defined. Again, you need to conduct the task. Yeah, so this is the example for program structure here. We start from the program start header, then program content of the body, then the program end. So this part with just from the 4-line here is, we call it the program header, because in this part we do not have machining. Okay, that means we do not have G0, we do not have G0, I mean G01, we do not have G02, we do not have G03, any of type either linear or circular motion for, I mean movement for the machines. So all part is, first is we have the definition for the program, then we have the tool to select the tool, then we need to define the either absolute or incremental, and we need to define the reference point or new reference point for our machine and so on. Or this part, we call it the part or the program header. Then this part will be more involved in the machining operation, which we have, you can see here G01, G01, G02, G01, G03, G01. All this part is more on the, which involved in the movement or in performing either cutting, drilling, I mean, lathe or turning and so on. Then you go to the end of the program. You start from going for the 0 point, for example, and you send to, or you return the spindle to its reference position. Then you go for to off the machine, I mean the spindle, and then to end the program. You can see here. So here, the first, which is related to the header, you can see in the header here we have the first part in the header that you need to include in your program is the program name, and program name always start with the O, with the letter O. You can see O00010. So O here is represent the program name, or it's the address for program name. Then the second one, we have N1, T1, M06. So this will be T1 with M06 will be used to change the tool that we are going to use. As we said, we have automatic tool changer, and in this automatic tool changer, we have different type of tools, and usually it depends on what is the required tool we need to perform. If, for example, if we are working on drilling, we are going to switch between the drill screw based on the diameter. For example, this hole is small, we need to use small screw. This hole is big, we need to use bigger screw, I mean, for the drill and so on. Based on the milling, we are going to change the head of the milling, for the milling, the head of the spindle here, based on also on the diameter of the spindle, for small blades, for the big blades, and so on. So the tool here will be used to, or in this line, we are going to define which tool we are going to use, and this also consider from the part of the header of the program. Then starting coordinates, like we said here, G90, G54, go to the reference for and return to the X -10, Y -10. We are going like to define the position for, or the main reference or the main starting point. Then switch on the tool to define the spindle speed. So here we have M03 to turn on the, I mean, to turn on the tool or the spindle, and we define the speed here for the spindle. What is the speed of rotation for this spindle? Tool length, which is like, for example, here G00, we are going to do, as we mentioned before, for G43, H01, we are going to consider the tool length or the length of the spindle, or the, I mean, the tool which is attached to the spindle here. We need to define all these in the part of the header or the setup of the program. Then we go to the body of the program. In the body of the program, you need to define also, this is the main part. Actually, the body of the program here represents the main part for the program, which more involved in the machining here. Okay, so you can see here, move Z level to 0 level. As we mentioned before, for drilling, when we talk about the drilling, we said we need to locate or place the spindle on a specific reference point on the top of the workpiece. So here we need to define the 0 level for the spindle here at the point Z .1, because it's more related to what is the level or what's the height or where is the position of the spindle from the workpiece or the work table, on the work table of the machine. Then based on the depth here, if you have N5, G01, Z -10, F50, here we are going to talk about the feed rate, and here we are going to talk about what is the movement in the Z direction towards the workpiece, and with a specific feed rate. Then start cutting. For example, here we are going to define the cutting process, which is at which coordinate and so on. I mean, All the part here, which is included in the middle of the program, is more on the machining operation. How many operation we need to perform? It depends on what's the requirement in the question or in the example or in the operation that we need to perform. You want to make, for example, to cut one place, you want to cut one line, you want to cut as a circle. So it depends on later, based on this requirement, you are going to define here how many coordinates you need to enter for to defining the path for your program. The last part here will be the tile of the program or the end. In this, after you finish, do either drilling, cutting, turning, and so on. You will ask the machine or the spindle to return to its reference point. The spindle go up, for example, from the workpiece, then return to the reference point, as we see before, to avoid any obstacles in between the spindle position or the current position and the reference point. So first, we take the spindle on to the top, away from the workpiece. Then we return the machine to the reference point or the 0 point. Then we need to end our program. So one of the type of questions that you may be or you will see in the future, either in the test or in the exam or maybe in the quiz also, it will be same like these things. You will be given such program, then I will ask you to explain what we mean by the first block, what we mean by the second block, what we mean by the third block, and so on. So your answer should be like comments here on each part of these blocks. So you should know this block, what we mean by T1, what we mean by G90, what we mean by S1520, what we mean by this, all these type of the comments. This one complete example for milling part or milling process here. Also, it's the program with its comments or explanation on how it works or what is the task performed without giving the graphic. I mean, we do not have the drawing for this part, for example. We have the program, and we should know how to translate or how to explain what we mean by this comment or what we mean by this block of coding. Okay, so the first thing here in this part of in this milling part program here is the sign, which is program must begin and end with this sign. So if you see this sign for the percentage, it's indicate the beginning and or the end of the program. I mean, sometimes I mean for the for the ideal structure of the programming, you should start your program with this percentage sign and end with the same sign here at the beginning and at the end of the program. Then the next part will be the definition for the program name. As you can see here, 010023, the program name. The one that we didn't mention before, I mean, in chapter 4, sometimes you need to add just one line for you have two options to add comments here. Either you write the code like this one. After the comment separator here, you write the comments to define what is this block means. So this comment will be more specific for this block of coding. Change to tool 1, that means you explain what you have in this code. But sometimes you need to use some general comments for your program. That means I want to define or to write some comments for the whole, I mean to explain to the operator what this process will be done. So in this case, we are going to use two brackets here. For example, like this one, mail part program example. So we define here, we give a comment in the area here to this comment will explain to the one or to the operator what this coding is for. So this one, for example, mail bar programming example. Then we have another bracket here, enter diameter offset for D02 at 0.625. Here also knows for the operator to enter the diameter for the offset. Okay, you can see here you use bracket always. If you see any code or any writing here on the coding with the bracket here, so in this case, this represents a comment. It's not executable part. This block, it will not be executed. during the running of the program, because it's not a code, it's just a comment, but this comment is just come, or it comes as a complete line, whole block of the code which consists just comment. And this will make easier for the operator to run the program or to understand how the program is working. Then we start here to do some of the, I mean, you can see here there is no n, because n, the sequence is just by default, it will be n1, n2, or n10, n20, and n2, and 4, depends on. So here we start from the first here, it's more on the tool change to tool 2, number 2, and was the this news here, I mean, in this line, to change to tool number 2, and between bracket here, this comment is for the operator to show, I mean, notes to the operator in between brackets, just to see the diameter of the tool is 5/8, and it's 2 flat end milling. So we define the type of the tool is not for drilling, it's not for turning, it's used for milling here. So this comment between brackets just extra explanation or description for this code, which is T2M06. Then go G90, G54, G00, and this or G code, which is like model, such model code here, to define the absolute, the work offset, the rapid movement, and so on, coordinates as we learned before. Each one will be explained here. Then if you have such, I mean, if you already start to do, for example, G01.65 at feed rate of 50, then this definition for feed rate for the previous one, I mean, this is the fast feed to deeps. I mean, in the depth, when we say deeps, that means we are talking about the Z, because in the milling we have the Z is represent the depth of the machine. So the movement on the Z axis represent the depth of the movement for the spindle. So when we talk fast feed to depth for 50, then go for the next one, which is G41. We define the coordinates, which is 2. Then we talk about D02 F16, which is Qatar compensator here that we talked before when we said G40 is for canceling, G41 for Qatar compensator, G42 also for Qatar compensator. All these definitions go in details one by one. You are required to go through to read and to understand how we can translate or how we can convert this code to explanation or this explanation into a coding. If you have just there is no G code, we have already here one G code, G01, we have G41, and this all the coordinates in between will be affected by the previous movement, which is the G01 or linear profiling. So linear profiling will be applied on all these coordinates: x2, x -2, x -2, y 2.25, and so on. I mean, until we got another this G41, the compensator will be cancelled by G40. So G40 will cancel the Qatar compensator here. Then we go for again G00 will cancel G01, because we said this G model will be affected until we come with another G model, which is G00. Again, we have here M09 for coolant off. Previously, we already have some, I mean, for coolant on or to open the coolant here to off the coolant. Also here for stop this such comments, these just notes for the operator or comments to operator is not executed. Then we go to the tool 3, we change to the tool number 3, and the tool number 3 for here the comment is stop for drilling. I mean for stop drilling here. So this is tool change to tool 3, not to operator. So in this case, if you want to change the tool, you need to have to stop the machine first, then you go to again to run the machine again. You want to change the absolute to coordinate to incremental, you want to change the incremental to absolute, it is the same. So I mean it depends on what is the preferable by the operator. Same also if you want to consider the compensator for I mean for drilling, or you do not consider for cutter, or you do not consider the compensator. We are going to see example on the more on the compensator at the end of this chapter. Previously we have mentioned the code for compensator. I mean, for the compensator, which is G40, G41, G42. Then we are going here. We are going to have some example about this code. As you can see here, you can see the program is a complete program, and it uses multiple tools. Start from tool number 2, perform some task, then stop. Okay, then again we are going to change the tool to tool number 3. We perform some task, then go stop. Then we go again to perform. I mean, to change the tool to tool number 4. We perform some task and so on. So that means within one operation, you can perform multiple type of tasks. Depends on the tool that you require, either for drilling, for milling, for turning, and so on. Also, if you want to use drilling only, but drilling some holes with different diameters, so you need to change the tools. So in each time, you need to perform the first phase, like in the first phase, until complete the first phase, then you return the machine to the 0 point. The first phase, you return the machine to the 0 point. After you finish the first phase, I mean, you go to the next phase, you change the tool, you perform all the tasks, then you return the machine to the 0 point. So it's like, I mean, if you are or you given task to write a program for multiple tools, it will be like this one. First, you define the first tool, all in between what you need to do. Actually, from where we write this information, the one that we see here, X, Y, Z, F, all this will be given, either given through engineering drawings, or will be given in a table for information. So the task will be just to have such coding. We are going to see complete example for this one. Okay. Instead of developing a program or a complete program from scratch, there is some like micro or some like we mentioned before for the canned cycle and the fixed cycle. For the drilling, we said there are some already existing canned cycle which is used directly to make a drill with specific tips, and this this operation will be repeated automatically by using just one code. When we say, for example, we define one code here, we have some for the several CAD cycle which is for drilling. When we use just one code, this one code will perform a series of operations by using just one coding. The same here, we have some of the automatic programming of machine cycles here, or some of the models. Actually these models for NC here definish already or can be used to perform complete tasks, like the case of the cycle or the canned cycle or the fixed cycle that we mentioned in chapter 4. Okay, and we are going to take some example about the canned cycle and fixed cycle in this chapter. So the idea here, instead of developing a complete program to perform an operation, then this complete program will need to recopy again and paste into perform the same operation. That means we have a repetition for this operation. We make it like a sub program or like one cycle, and this cycle includes several codes inside, and this several codes inside we are going to call it by using one command, and this command will call this cycle to be running for 1 time, 2 times, 3 times, based on the requirement of operation, and it will be repeated again. So some of the existing modules here for such NC operation, like profile milling, pocket milling, engraving, counter turning, facing, threadings. All this operation is ready. I mean, like it's come like one is come like a complete cycle, and this cycle will be used to perform one specific task. As you can see here, if I want to use the pocket milling here, so the pocket milling, it can create such pocket on the workpiece or on the work part. So if you have a work part, you want to make a pocket milling here, you just run the pocket milling modules, and it will perform such tasks. It gives you similar to this operation. You need just to define the dimensions of this pocket. If you want to have a counter turning, for example, as you can see here for the part B, the counter turning is responsible to create such path using the turning tool here. So this turning tool will go, will define the specific path to go through. based on specific coordinates already defined inside the model. Same like the previous one, as I told you, for the can cycle, we have this can cycle can perform or create a hole on the workpiece, and I need to define just what is the depth of this hole and what is the coordinate of this hole. So, and this process will be repeated automatically. I mean, repeated when we call this command for the can cycle. The same here for either for bucket bearing, for contour turning, for facing and shouldering here. For shouldering part here, we want uh, on the face shoulder or for the facing tool here. So the facing tool, this part or this model will be used for facing and shoulder facing in the machines. You want to make threading for like we have like this the threading part that we mentioned before in chapter 3. We want to work with the thread. We have a specific modules for to do the threading here. You need to define some of the coordinates for this part. The idea behind this one, if you have repetition for perform the same task like this one, so you can see here the thread here. How many threads do you have? As we mentioned before in chapter 3, we said we need to define some of the parameter related to the threading here, like the number of page, the angle of this page, and so on. So usually they have such like add-on modules for the CNC machine. It is specific to perform such type of the task. No need to create program to say or to ask the machine go linear to this point, then go circular to this point, then again go circular to that point, then again linear, then return. No need to go to ask the machine go straight line, then circular, and so. You just need to use the turning tools or the turning modules here. So these turning modules will be used to perform the task of contour turning. This face and shoulder model will be faced to use this task. This will be used for that task and so on. Some uh, functionalities or add-on modules for the CNC programming it can use to perform specific tasks. We will stop